Our next keynote is new to FMS. We're really excited to have them. They're one of the emerging companies in the whole virtual infrastructure space, a very exciting space right now that memory and storage plays in. The name of the company is VergeIO, and I'm honored to introduce to you their Chief Technology Officer, Jan Ness, who's an entrepreneur and infrastructure strategist with over 25 years of experience leading technology companies through transformation and scale. As CEO of VergeIO, he guides the company's vision to simplify IT infrastructure and employee organizations to operate sovereign and private clouds with great efficiencies. Jan earned his Bachelor of Science degree in Computer Science from University of Michigan. Along with him will be Greg Campbell, who's Chief Technology Officer for VergeIO. He's the architect behind VergeOS and a veteran in scalable system design. With a background in distributed computing and a passion for eliminating infrastructure bottlenecks, he leads VergeIO's engineering efforts to integrate advanced capabilities like AI into the core of the operating system. Greg earned his degree from University of Michigan, Dearborn. I'd like to welcome to the stage, and if you can give a round of applause for Jan and Greg.
Thank you, sir. First of all, nobody's ever confused me with the CTO before, so we'll let Greg do most of the talking today. Let's see, but let's start with, let's see, what do I got here? We're going to talk about software. You guys are a lot of hardware people here. Greg has some really, really interesting things, and our job here is to tell you about them. We're not here to sell you on VergeOS, so let's get started. Again, my name is Jan Ness. I'm the Chief Executive Officer of VergeIO.
And I'm Greg Campbell, the CTO, and founder of the company. Actually, we began our journey as Yottabyte about 15 years ago, and so really began concentrating on the storage problem, but with the whole vision of really virtualizing the entire data center, which is what we became with Verge now.
Yeah, so Greg's been working on infrastructure software for 15 years. He's seen a lot change with hardware and software, and that's what we're going to get into here in a minute. But a little bit of background on who we are and what we do, just to set the context. VergeIO is a pure play software company. Our product is VergeOS. It is infrastructure software that runs on your x86 hardware. What we do is we pool all the resources, GPU, CPU, RAM, storage, network, across many, many nodes and present that up as if it's a really, really big computer. Then we allow you to organize those resources into what we call virtual data centers, not virtual machines. So think of like we do to the data center what VMware did to the machine. So our level of encapsulation is the entire workload. So think BGP, compute, network, storage, DR, backup, orchestration, all of that is encapsulated in this entity, which is actually pretty cool software, by the way. And one of the things Greg's going to spend some time on is architecture. We are a single piece of software, one code base, one GUI, one API. There's only one thing to know and one thing to learn, and you get just an immense amount of virtualization platform. There's a huge benefit to that Greg's going to get into, which means we're purpose architected for replacing VMware. Everybody knows who they are. A lot of people want to do that right now. We got lucky there. Thank you, Broadcom. Running private AI and a whole bunch of other really, really interesting high-performance workloads that require a lot of agility and a lot of security. If you want to see it, come on by the booth later on. We're glad to give you a demo. But first, I'm going to show just some data really quickly that I think many of you are going to be familiar with. In fact, some of you should pat yourself on the back about this data. Again, software is the problem, not the hardware. If you look at storage, over the past couple decades, I'm old enough to remember like 8-inch floppy disks. I think some of you are old enough to remember those as well. We have a great partnership with Solidigm, by the way, and we've got one of their 122 terabyte disk drives in our booth. It sits in your hand. So performance, density, storage, you guys have done a phenomenal job. And seeing what some of you are going to release later on this year and next year, it's kind of mind-boggling to those of us who have been doing this for decades. Same with network. I remember the 1 megabit port, the 10, the 100, the 1 gig port. My last hosting company was a premium product. It was very expensive to buy and deploy. And now, we're pushing 2,500, 200, 400 with NVLink, 800 gigabits. Another really, really good job by the hardware world. It's just, it's actually mind-boggling. The next one, though, I mean, we're in Intel's backyard, and when you look at CPU cycles or clock speeds, we haven't seen the kind of commensurate exponential growth that you guys have delivered in storage and the networking experts have, which presents some really, really interesting challenge to modern day software demands. If you want to use the workloads, run the workloads of the future, we think it's a software problem. Now, look, Intel's a great company, AMD's a great company, but we use gaming chips to run AI workloads. It's kind of odd to me, actually, but we do, and it's the best use case for those today is all the AI engines. Now, Intel and these CPU providers have been doing some performance gains. Greg, why don't you? I mean, what have they been doing if they haven't been increasing clock speed?
Right. So, I mean, a lot of the focus with, with CPUs obviously has been, parallelism, lots of cores, power efficiency. But, if you look at what I can do with a single stream or a single process on 5-year-old gear versus gear today, it's not that different. I can do a lot more in a box, but I can't do any one thing that much faster. So, it's a challenge for software, and we have to think of that software architecture to keep up, which I'm going to kind of talk about my journey, what I've kind of seen throughout there, and what we're doing different at Verge to accomplish it, to solve it.
Yeah. We'd love to see Intel get that, become the next NVIDIA, right? That would be kind of cool to get some competition going here, right? Wouldn't that be cool? Especially right here in their backyard. So when Greg and I were talking through about sort of hardware versus software and what's happened over the past 20 years, I asked him, our marketing department asked them, give me some imagery that sort of, he told this story. It was a really, really cool story, and you're about to hear it. But we asked, give me some imagery around this, because we didn't want to put up a bunch of slides with a bunch of words. It's kind of boring. No offense to everybody else that's been up here. But, and he came up with this imagery of, everybody knows the story of the tortoise and the hare. If you don't, look it up. It's fascinating. It's a great children's fable. Why did you pick this, Greg? What was going on here?
Yeah, so, obviously the rabbit is software. And, I kind of look at, it's building infrastructure software, our job is to build the software representation of hardware, right? And to gain some benefits by doing that. And, so from a performance perspective, I mean, my job is to make sure the software does not get in the way. I want to always be able to point to that piece of hardware and say, that's the bottleneck. When I began this journey, it was pretty easy. When you look at spinning disk, we're measuring latencies in milliseconds, sometimes even tens of milliseconds. Networks are in the single digit gigabits, and so the focus was a little less on. At least it was a little easy to kind of maximize that performance. So we were able to focus a lot on feature sets, and they'd really realizing the advantages of having software, managing our hardware and kind of entering into some of that software-defined era there. And so one of the approaches that we would take at that point is a very modular approach. And so when we build our software, we take advantage of being able to break up the software into lots of different components. And there's some very good advantages to doing that. One might be that we can have a lot more developers work on features because we can break things up into different teams. We can expand feature sets through acquisition. We can leverage open source components, and we can stitch all these pieces together and accomplish what we need to do without the latencies and everything between there is just not that big of a deal, right? So we can recognize a lot of that. There's some complexity that comes with it, but it's not difficult, right? It's pretty easy.
Didn't that also result in a little bit of bloat, like a lot of lines of code too?
Lots of bloat, but like I said, at that point, at that time, wasn't that big of a deal, right? But then things started to shift.
Yeah. So what happened next?
Yeah. So then Flash and solid state, and more specifically, what we saw was again kind of on the backdrop of CPU performance it's increasing, but it's it's a little more of a steady rate, and all of a sudden this Flash thing comes out, and now we're dealing in 10x, to plus, right? And so now the rabbit has to pay attention at the very least, and during this phase, we're becoming a little more aware. We got to maybe tune some functions. We got to optimize. We're looking at what can we offload and hardware accelerate. We're throwing, doing encryption on chip, or we might do some, erasure coding with some hardware acceleration or compression. We're tuning, functions and algorithms, but for the most part, we can still keep up. It's and I don't think at this point we had fully realized the potential of where this was going. A lot of we were still leveraging some of the same tech that we were using with spinning disk from controllers and so it's those latencies and everything in between all these different components still wasn't a big deal. But at the same time, during this time, I'm looking at kind of realizing what is coming and what the true potential to Flash and by the way, networking as well is also keeping up and seeing those same types of 10x bandwidth improvements. So during this era, we kind of bounce back and forth between storage is the bottleneck, network's the bottleneck, software's for the most part keeping up there, but it kind of brings us into the next phase of things where all of this kind of comes crashing down, and really we need to kind of rethink the underlying architecture of the software to really address it.
Yeah. You hardware guys are doing too good a job, so congratulations once again. So the next hardware sort of generation of storage at least and networking, more exponential growth and density, more exponential growth in IOPS and performance. Do talk about latency a little bit, because you had some really interesting things to say. Is it IOPS I want? Is it latency I want? And so forth. But
yeah, and again, a lot of at least on the software perspective, what we're seeing in processors, and everything's going more parallel at that point. And one thing we would start to see as well is you see what the hardware is capable of doing at the lowest level, and we do thank you for the vanity benchmarks. We love those. But you start to there's a big amount of space between the hardware up to the workload, right? We have hardware because we want to run workloads, not because we like to collect hardware. Well, maybe I do, but so what when you get the massive parallelism, I can do a lot of work, but a lot of times individual depending on how the software is written, you have to work with single stream performance, and that's where we just haven't been able to keep up as much. When we're dealing with thousands, even tens of thousands of things per second, not a huge deal. But when we start looking at latencies that translate into millions of things per second, every little bit of latency just it adds up. And even things that should be fast, like talking to the kernel and coming back, it just can't keep up. Or context switching, you start to hit a lot of bottlenecks, and you really got to start to rethink some things.
Right. And the rabbit's about to get in big trouble here on this next picture. So why did you pick this imagery?
Right. So this was this is kind of that final phase where the traditional architectures are just not going to be able to keep up anymore. There's too many pieces to the puzzle. When you get to the very top there, and it's just with that architecture, it doesn't matter how much you tune the individual pieces. Just the latencies going between them are just going to be too much for it. So a lot of this obviously came across once we started to eliminate some of the controllers. We get NVMe. We can talk directly to these devices, and all of a sudden now we have access to millions of IOPS and everything at the lowest level. But to actually get all of that through the entire stack up to your virtualized workloads and the virtual data centers is it's too difficult to do with those. So what we did at Verge is we kind of we had to re-architect, we reimagined this, and we switched from a more of a modular design into a monolithic design. So that means we're putting everything, we're eliminating all the layers, eliminate the stack, and put it into a single code base. This even means things like, we have to do our own memory management, we have to do our own threading, we have to, a lot of the stuff that we might have leveraged pre-existing code for, or the kernel to do, we have to kind of move into and really look at every step of the path. Little double buffers between the hypervisor disk cache and buffers versus the lower end. We got to eliminate all that, get into shared memory spaces. There's a lot that we have to kind of rethink, and it's a different architecture to pull that off. Luckily, like I said, we had kind of seen that coming and built it that way, but there is still some more to go. And more recently now with AI, it's kind of made the problem even worse.
Yeah, so AI did not make this issue go away. It didn't make this issue easier to solve. Do talk about the difference between complexity and simplicity in a minute, and difficulty, because you've got a really interesting thought there. But AI makes this a really, really big problem. The software for running AI workloads in a virtualized environment, especially like private AI, where it's using your enterprise data inside your walls and completely controlled by you, with models you may have built yourself or downloaded and trained, and then providing those in a secure private way to your employees or your customers, whatever you may need to use there. That made this a lot harder, right? Don't you speak about that for a minute?
Yeah, well, it's a lot of the same problem over again. AI is very demanding of storage. It's demanding of the network. It's very, very demanding of the compute, and it's not just much like when we look at storage benchmarks and those level. We concentrate on the hardware only. Again, kind of looking at some of those more the vanity numbers, and even with AI, we're looking at tokens per second and everything. But there's more to the story than just raw hardware performance. To get to the end workload, even with AI, there's more and more layers that are appearing. We're getting into agentic coding and full workloads, and now we're involving multiple models simultaneously to solve the same problem. We got orchestration, we got GPU placement. There's a lot of different layers that all same problem all over again. And so we looked at what we've done for the data center and trying to virtualize and liquefy all the hardware and get that hardware abstraction layer. And we thought, why don't we do that with AI as well? And so a lot of the hardware-based problems, we had already solved. We're for the most part, we're already working with GPUs. We're working with vGPUs. We're already virtualizing the network and the storage. We're already doing resource planning and mapping and orchestration. So it wasn't a huge lift to begin to add that in there. But then we also started to take the same monolithic approach that we've been taking, which, to your earlier point, it's not easy. It is very difficult to put this stuff together into a single code base. But the end result is that what you end up with is simpler. It is nowhere near as complex as before, which also has some other benefits too in terms of reliability, security, because I don't have all these different things that have to be open to talk to each other, compatibility. A lot of that starts to go away. So we wanted to do the same thing with AI. So we began to virtualize this whole AI stack, build in the vector databases and just the whole workflow, and kind of put that all in the same code base. And so that's actually what we are just now launching right now this month with our new VergeIQ.
Yeah, and just to take that one step further, when we talk about sort of the infrastructure of the future, which is what our software delivers, we are building a senior principal engineer, VergeOS senior principal engineer, into the product. So you'll be able to, we think the interface of the future for your infrastructure is chat or voice, not GUIs, not even API. And so what you'll be able to do, and this was something we already sort of solved the hard part of making all of the CPUs and GPUs kind of work across these nodes. We will have a senior principal engineer built into the help system in VergeOS that will have direct access to your metadata and your infrastructure. So you start chatting with it. You ask it questions like, hey, I noticed my application was a little slow last night over in this virtual data center that you guys are running. Why is that, and what can I do about it? We have a number of dark sites where the software is running inside a SCIF for some DoD related companies. And obviously that ability to interact with their infrastructure as if Greg was there, like we want a virtual version of Greg inside the software. We think every software company needs to do that. It's just that it's really, really hard to do that. And that's what Greg has figured out how to do and our North Star is keeping things simple, right? Make it simple, make it easy, which as Apple has showed all of us, is very, very, very beneficial to the consumer and all of us, but actually takes a lot of thought and a lot of work and a lot of energy in order to make things simple, which we're doing with VergeIQ. So you use this term that, God, I love these images. You use the term, we need a new developer mindset. What do you mean by that?
Yeah, well, I actually like the analogy of kind of the system on a chip, right? So I mean, again, the hardware approach has already seen some of the same problems in a different way, and its latencies add up. The distance from here to here, it's too slow when we're dealing with these speeds. So you take a system on a chip approach where you put everything right next to each other, and now you get all these extra efficiencies. And basically, we're copying that. We're going to do the same sort of thing with software. That by pushing all these different things together, kind of going the opposite of what we've been doing for years with more modular approach, we're able to hopefully continue to keep up with where hardware's going.
Yeah. So just to level set, you might wonder, that's great. So you monolithic single piece of code base. Why the hell do I care? What does that do for me? Well, let me give you some examples. We have customers running, these virtual data centers on x86 boxes. Sometimes it's like 4, 5, 6-year-old boxes, which I know Dell doesn't like, but it does. It runs just fine on older boxes. And they create this virtual data center, and inside there you put these Linux or Windows virtual machines. And you have all your networking and your 4 or 5 tiers of storage or whatever you're doing there. And it can be running, let's say, SAP, or we have one large customer that's doing like human genome sequencing off a cluster of GPUs inside a virtual data center. And it's taking 30, 40, 50-hour runs, by the way. We beat a bunch of our competitors on those performance tests. You can take a snapshot of that entire virtual data center. It could be a high-performance SAP implementation at a manufacturing plant. It could be doing human genome research algorithms. It could be doing remote desktops. It could be doing whatever you're doing inside that virtual data center. And you can take a snapshot of that thing, how fast?
30 milliseconds, even if it was a petabyte, it doesn't matter.
So you got a 500 terabyte virtual data center up and running in production. You take a snapshot of it, You go into it, you click select all on the 100 machines, and you boot them all. Storage Review in their lab showed us booting 1,000 Linux machines in 70 seconds. We demoed to one of the hyperscalers, VergeOS running on a bare metal server. We imported and booted 100 Linux virtual machines from a VMware environment off-prem in less than 10 seconds. When you take that snapshot of that whole virtual data center, it doesn't use any more data until the data begins to change. So with this monolithic single piece of code software base, and we want to run on the cheapest, fastest hardware you got. We don't want any error correction going on. Greg does all of that inside the software. So there's all kinds of benefits with this monolithic software approach, and even maybe running that software on chips inside the hardware. So this notion of a virtual data center that's delivered with a single code base where everything happens inside the software does deliver agility, security, scalability, performance that you just can't get any other way.
Right. And you could start to do things that you didn't really think of doing before, because with this,
right.
And we say snapshot, but it actually acts more like an instantaneous clone, because it truly is a bit perfect copy of what was there, with no relationship back to the original. But because this layer of hardware abstraction that we have is at the data center level, everything goes along for the ride, and everything is, it doesn't really care what hardware was underneath. So, I can do things like have, an entire, data center implementation of, my web servers, database engines, whatever it is, make an exact copy of that, IP addresses, MAC addresses, firewall rules, users, all the machines, all the storage, everything is now in this separate virtual bubble, this other world that I can now run in parallel, whether that's to, maybe test out an update ahead of time and see what impact it might have, or if I want to send a production environment to QA to try to reproduce something, they don't have to reproduce it. They can get the exact same copy of it, in runtime. And you can do it all instantaneously as fast as you can click. So it starts to, ransomware becomes as simple as just rolling back what it was a few seconds ago or whenever the event happened. So it does change kind of the way you do things.
Kind of like digital photography, we can move around virtual data centers like people move around JPEG files.
Yeah, it's portable. I could pick it up from one location, yep, drop it over here, and even switch from Intel to AMD at the same time without, it completely different from, doesn't matter what the hardware is underneath at that point.
Yeah. So what's next?
Yeah, so, we got to continue to keep up. Our job is to always not be the bottleneck, right? And although we believe we have the right architecture to move forward, this is not done. There's more we can do. We're looking at things like, do we start to live in other areas of the infrastructure? Should we be putting code in individual cards and DPUs that might be sitting, kind of outside of the workload space? Should we be putting more code into our network cards or even our solid state drives themselves to get even closer to the edge to, again, eliminate these latencies. And then obviously with the AI side, we talk about VergeIQ and kind of where we want to go with that. We want to bring all of that to the table as well. So we still have a lot we want to do next with AI to not just give you the virtual support agent, but to truly make it a part of your team and give it a little bit of agency to be able to, do some predictive analytics, to be going through your logs, to let you know that, something might be suspicious, and not only alert you to it, but give you a recommended action. And then as, the captain could just say, make it so, and then it'll go and auto disable those firewall rules for you or whatever it needed to do. So there's still a lot to continue to add to it, but.
Yeah, pretty exciting. This guy's been building this software like this for 15 years. He knows a lot about it. He's going to be at our booth for 15. If you want to come by, he loves to geek out on all the hardware you guys are building. He can't wait to play with a bunch of it. He's got a really cool lab. We get the latest, greatest stuff from a lot of companies. Come on by, say hi. Get a demo of what a virtual data center looks and feels like. Get a demo of private AI. We took all our internal, external marketing information. We did this like an hour before we opened the booth, by the way. It's really, really simple and easy. It's hard to do, but Greg made it easy. Uploaded every piece of marketing content we have, internal and external. Come on by and have a chat with VergeOS agent that is hitting our marketing department content. I think they'll be fine with that, right, George and Sarah and Aaron? Yeah, I think so. So come on by, say hi to Greg, get a demo, and let us know what you think.
Yeah, we'll see you then. Thank you very much, everybody.
Thanks, everybody.